So I'm a systems engineer at Google. How many of you know what a systems engineer is? Wow. So for us, systems engineering is kind of looking across the project and making sure that the software and the hardware and the sensors and all of the computers, they all work together and they do exactly what we want them to do. But before I got there, I used to live in Bozeman, Montana. And that's where I grew up. How many of you have heard of Bozeman, Montana? Wow, a couple, that's great. So Bozeman, Montana has 20,000 people in the entire city, and it's a pretty amazing place to grow up. When I was in junior high, so about you guys' age, I wanted to be a professional musician. We're in the museum. And then all of a sudden I went to a science class and my science teacher was teaching us about Mars and he was talking to us about Viking landers. How many of you have heard of the Viking landers? Awesome. So the Viking landers landed on Mars in the 1970s. How many of you were alive then? And I got really excited about landing on another planet and exploring a new place that no one's ever been before and really learning about this new environment that we know nothing about. And so I decided that's what I wanted to do. I wanted to send stuff to Mars. I didn't know what that meant, but I knew that that's what I was going to do. In high school, I was a cheerleader and was super into like dance and music, and I was on my way to enjoying math and science a lot. And so I was in a math class, and my math teacher said, "Jaime, what is it you want to do?" And I'm like, "Well, I'm not really sure. I don't have a name for what I want to do. I just know this thing that there's robots and they go to Mars, and I want to work on that." And he said, "Oh, that's engineering. I think you should be an engineer." And I'm like, "Well, engineering, isn't that something that boys do?" And he looked at me and he said, "No, engineering is for everybody. It's amazing. And you get to do math and you get to do science, you get to write code, you get to do all of these fun things every day. And that's how you get to put stuff on Mars." And I was like, "Sweet, I am going to be an engineer." There are lots of different kinds of engineers. There's mechanical and chemical and software and computer science and aerospace engineers, and I thought, well, I want to send stuff to Mars. I should probably be an aerospace engineer, right? Is that smart? So that was my new plan. And so then I went to college, and my freshman year in college, I was really trying to figure out, okay, what is this engineering thing? I'm taking engineering classes. And so I had a teacher, and he said, "Jaime, you want to be an aerospace engineer?" And I said, "Yeah, well, I want to send stuff to Mars." And he said, "Well, let me tell you, aerospace engineering, mechanical engineering, they're a lot alike. And the cool thing about mechanical engineering is you can work on cars, you can work on planes, you can work on robots to go to Mars. Like there are a whole bunch of really cool things you can do as an engineer that's doing mechanical engineering. And when you do aerospace engineering, you can actually do all of those cool things too, but you kind of have a label that makes people not realize that you can do all of these other cool things." So he said, "You might think about mechanical engineering." And I was like, sounds fun. I can build robots still? I can still go to Mars? And he's like, "Yeah." And I was like, "Okay, I'll be a mechanical engineer." So I switched my major to mechanical engineering. And then in my sophomore year, magic happened. Pathfinder landed on Mars. And it landed on the 4th of July, my sophomore year, and I was in heaven. I was like, "See, that's it. That's what I want to do. It's still there. It exists. That's what we're doing." Because we hadn't landed on Mars since the 1970s. And now it's the 1990s. How many of you were alive in the 90s? A few more. So now it's the 90s. We've landed on Mars again. This is a real thing that NASA is doing. And I was like, sweet, I am going to be a mechanical engineer. And now I know where they do this thing, sending stuff to Mars. Because before I was like, I'm not really sure what company is sending stuff to Mars, but it looks like NASA's doing something somewhere. And so I found out when Pathfinder landed, that's the NASA's Jet Propulsion Laboratory. Anybody heard of JPL? Awesome. How many of you have been to JPL? Oh, you have to go. It's a magical, magical place. They send stuff to Mars, send stuff to space. And I realized that that's my dream job. That's where I want to work. And so my junior year, I was working at Perkins Family Restaurant and Bakery, which is kind of like a Denny's or a Bob Evans or an IHOP. And a couple would come in every day and I would wait on them. And they would come, and finally one day she said to me, she said, Jaime, are you gonna work at Perkins forever? And I said, no, actually what I really wanna do is I wanna go to JPL and I wanna send robots to Mars. And she said, oh, well my brother just retired from there. He's moving here next week, I'll introduce you. And so the lesson here is you never know who it is in your life that's going to open that door for you and unlock all of your dreams. And so you really just have to get out there and talk to people and network with them, because this lady brings her brother into Perkins and he says, oh, give me your resume, I'll pass it around to some of my friends back at JPL. And a week later, I had a job at Perkins. Not at Perkins, at JPL. I was already at Perkins, huh? So, you know, just by talking to people and building up a resume, I ended up with my dream job. And so I got a job as an intern, and I went and I worked at JPL doing really cool stuff, trying to figure out different landing technologies and what we might want to do when we go to Mars again. After my internship, I had 3 classes left, so I worked for a year as an intern at JPL, learning a whole bunch of different stuff, convinced them that they should hire me. So the next lesson is that when you go and you work for someone, you need to do an amazing job so that they can't help but hire you. And so every single day, that was my goal, was convince them that they cannot live without me working for them. And they did. They hired me, I got the job, I went back to Montana, I did my 3 classes, and went back to JPL. In the early years at JPL, I got to do cool stuff like this. This is a lander that we were testing. We were trying to figure out how, as a lander drops down from a parachute and starts to move, does everything deploy exactly right? Because the cool thing about going to Mars, and the really hard thing about going to Mars, is you can't touch it. You can't test it. Mars is totally different than Earth, right? There's not as much gravity, there's no air, it's really, 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 really cold, and it's really, 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 really hot. And so you have to take all of these tests and you have to figure out how to test all of the different pieces and then convince yourself that when it all comes together on landing day at Mars, it's going to be amazing. And so this was part of that program. I actually got to run the entire landing test program myself. I was in my 20s and running a $14 million test program. So the other cool thing to know about engineering is when you're passionate and you're really good at what you do, you can do amazing things, and it's not like you have to earn your stripes and get older and then it's all of the older and more senior people that are doing cool stuff. You're in your 20s, you've just graduated college, and you're in charge of figuring out how to land on Mars and test that and prove that out. So super cool jobs right away. And then magic happens, and your stuff's on Mars, and all your dreams have come true. And this is Spirit and opportunity. Cool story about the top, that's Spirit. Spirit landed on Mars, and parts of her pieces shed as you're coming into Mars, you're dropping off a heat shield, and you're trying to get everything away from the rover before it gets down on the ground so that it can drive and not be wrapped in all of this protective stuff that you've sent it in. And as she was unwrapping herself coming down to Mars, she dropped off her heat shield. As she drove around on Mars in those first couple of months, she found that heat shield. And I had been in the clean room before we launched, and the heat shield was sitting there, and it had some of my hardware on it. And so I went in one day with a friend of mine, and we took a big Sharpie marker, and I wrote Jaime in letters this high on that heat shield. And as the rover is driving up closer and closer, me and my friend are like, oh my goodness, it's gonna send back pictures. I am so fired. And the pictures came back, and there had this blanket folded right over where my name was at. So no one saw it. I didn't get fired, but I was pretty stressed for a week or so. But engineering's fun. And so here's what it looks like to have all of my dreams come true. We landed on Mars. They were there successfully. Everything worked. And I want to tell you a little bit about what it's like to be an engineer. So then I got put in charge of the Curiosity landing system. And I was the lead mechanical engineer running the team that was figuring out how to design landing gear that lands on Mars. The cool thing about Curiosity is there's no airbags. There's no lander. it just lands on its wheels. And so we had to do a lot of tests like the one you're seeing there, where we had to figure out exactly what it means to land on your wheels when you don't get to pick your landing spot, right? So there can be rocks, there can be slopes, there can be sand dunes, and all of those things mean different challenges to the rover. And so we built lots of early prototypes and we tested all of those out. So this is something we call Scarecrow. She's our earliest version of what that rover was going to look like. And we called her Scarecrow. Does anybody know why we might have done that? Yeah.
Because it looked like a scarecrow and it wasn't very technical.
It looked like a scarecrow. Not very technical is a good clue. Yes.
It was on Halloween.
It was on Halloween? No. Has anybody seen The Wizard of Oz? What's wrong with Scarecrow?
He doesn't have a brain.
He doesn't have a brain, and this rover didn't have a brain. There was no code running on the rover. It was all just a button box. So that's me. That's actually the rover that's now on Mars. That's Curiosity. And that's all of the hardware that me and my team built. And so that was one of my last deliveries at JPL was delivering all of that. And it's a pretty amazing time. You get to design the wheels yourself. You get to design the suspension. You get to figure out exactly how to land and drive on Mars. And then you have to go to Florida, and you have to put your baby in the tippy, tippy, tippy top of a rocket, and you have to say goodbye. And it's gone forever, and you can never touch it again. And that was a sad but exciting day. So we launched in 2012. And then 9 months later, she was on Mars successfully. Who watched the Curiosity landing? All right. How many thought that was super cool? Yeah. So Curiosity lands successfully on Mars. It's an amazing night. She's been there now for a couple of years, and she's successfully collecting a ton of really great scientific data, and that's pretty fun. But now I had landed 3 different rovers on Mars and was kind of looking for what's the next thing in my career. And so self-driving cars on Mars, I was like, maybe self-driving cars on Earth, that might be fun. And so I came to Google. How many of you have been to Google and toured Google? Google is a crazy, fun, silly place. We have light, bright walls. We have silly, colorful bikes. We've got fun places to work. And it really is like you see there. Always interesting, fun things to look at. And they really make it a place where you can be creative. A lot of people ask me, is it like that movie? How many have seen that movie? The Internship. Yes, it is like that movie. We have silly hats with spinny things on them. We make all of the new people wear them. We talk about being googly. We ride those bikes. We do play Quidditch. I've never played, but there are Quidditch tournaments at Google. And we do have what?
Self-driving cars.
And how many people think self-driving cars is the coolest thing that Google does? Oh, yeah. So why do we do self-driving cars? Well, there's lots of reasons why you do self-driving cars. So, self-driving cars is a really, really important technology. And it's something that a lot of people are working on now. Uber has come out and said they're working on it. Tesla's got some stuff going on. And it's amazing what you see when you're out driving on the road. And I encourage you guys, as you're riding around on the road, just looking at the other drivers around you and what they're doing. They're talking on their cell phones, they're shaving their head, they're eating breakfast, they're putting their makeup on. I do, I have the trumpet playing guy. We actually saw that. We took that picture because this is what you see when you're out. There's also the fact that people are just in cars commuting a lot. There's a lot of hours that you could have back doing more interesting and productive things with your life. So I'm pretty excited about this technology. And this is the car that you see today down in the museum. And that's the car that you see driving around Mountain View. Pardon? So this car is equipped with a ton of lasers and radars, and it's my team that's really taking all of that together and testing it and making sure that everything is working exactly the way we want it to. And in a couple of weeks, you're going to start seeing this car. It's a Koala. I have heard it called a Koala. Thank you. We love her. This is our latest baby. We've been testing her for about the last 18 months. And we've got a ton of work to go, but this is our latest prototype vehicle. And we're really excited to start learning more and more about self-driving as we get stuff on the roads. That's it. Thank you.
Wow. Well, that is some incredible work that you've been doing. And I bet that a bunch of our students here today have some questions. Does anybody have questions for Jaime? She'd be more than happy to answer. What about the Rover project? Any questions about that? Any questions about Google? Yeah, we got one over here.
What is the record for Curiosity being on Mars, driving the longest distance on Mars?
So it's actually Opportunity that's driven the longest distance on Mars. She just drove a marathon. So finally she's passed 20 miles, and we're pretty excited about that. Curiosity is down at around 9 miles, which is still a pretty incredible distance, but not as far as we want her to go. She's still got a while to drive. She's trying to get to the top of Mount Sharp, and so she's about halfway up the mountain, and we're trying to get her further up, and we think there's some pretty interesting science stuff up at the top.
How big was the rover?
How big was the rover? So I think you mean Curiosity. So Curiosity is as tall as Shaquille O'Neal, and Curiosity's wheels are as big as the wheels on a typical car, but she's as long and wide as a Humvee. So she's pretty big.
How long did it take to build the rover?
How long did it take to build the rover? We started with Curiosity talking about how to land rovers on Mars that aren't wrapped in airbags in 2003. In 2007, we realized that we weren't going to be ready to launch when we wanted to, and we actually delayed the project. And the cool thing about Mars and Earth is that the planets get pretty close to each other every 18 months. And so if you don't launch within about a 2-week window, you really have to wait another 1.5 years before you can launch again, because you need the planets to get close to each other so that when you launch, it's just a 9-month journey instead of a 2.5-year journey. So if you decide to delay the project, you decide to delay 2 years. And so it ended up taking us from 2003 until 2012, so 9 years to do that project.
What kind of jobs can you get at Google?
What kind of jobs can you get at Google? You can basically be anything at Google. We hire education specialists, we hire philosophy majors, art majors, computer science majors, software engineers, we hire test engineers, systems engineers, mechanical engineers. There are a ton of engineering jobs. There's also a bunch of math jobs, but basically anything in STEAM you guys can do, you can do at Google.
How long has the rover been on Mars?
The rover has been on Mars since August 2013. I assume you mean Curiosity. Spirit and Opportunity have been on Mars since January 2004.
How many miles per hour do rovers go?
How many miles per hour do rovers go? We don't talk about it in miles per hour. We talk about it in centimeters per second, and they drive 6 centimeters per second, they drive 6 centimeters per second. So that's effectively going. Top speed. It would take it 45 minutes to drive the length of a football field.
Do you have more rovers or?
Do we have more rovers?
Yeah.
So the cool thing about sending a rover to Mars is that you never get to go touch that rover ever again. And so you really want something on Earth that you can test with and you can make sure that you're doing the right things. So when we have new software, we test it on a rover here. So Curiosity actually has 2 twins that kind of makes them triplets, except they're kind of different, so we call them 2 twins. But one of them is exactly like the rover on Mars. And so there are more here on Earth. And if you go to JPL, you can go and you can see those rovers.
So when you say never again, you mean until we get rocket ships that go to Mars, right?
Well, so it will be someone that is probably your age that will be the first humans on Mars. And if you would like to bring me a wheel back from Opportunity, I would love that.
I'll be sure to do that.
Thank you.
How many miles about do rovers last?
How many miles do rovers last? This is a really interesting question because Curiosity just drove over 20 miles, right? We designed her to drive less than half a mile. So she's gone 40 times further than she was designed to do. For Curiosity, we designed her to drive about 10 miles, and she's done about that. And so everybody keeps asking me if Curiosity is going to go 40 times further than she was designed to do. And that's all my hardware, all the wheels and everything that have to be able to do that. And I'm a little worried that that answer is probably no.
How long did it take you to build the rovers?
How long did it take us to build the rovers? That's a great question. So we do a lot of designing on paper, we do prototypes, we do testing. Then we finally decide what it is we want to do for the production build, the one that's going to Mars. We started getting those parts in 2009, and we finished putting them together and doing all of the testing and put it on the top of the rocket in 2012. So that's about 3 years. Just to build it and test it, that's after we've decided what it is we want to do.
What's the architecture of the rover's embedded computing?
Oh, this is where I'm a mechanical engineer and I don't really know. We write our code in C, not C++. And we run a lot of RS-232 embedded communications. Does that mean stuff to you? Okay. That's about the limit of my knowledge.
Actually, one of the girls in one of my groups asked this question. Is it possible to hack into a Google car? And if so, what is Google doing to try to prevent that?
That's an amazing question. So the good news right now is that there's always people in our cars. And so getting a physical hack is the best way to hack into a Google car. And you can't ever do that because we have our own people in it. But we've designed it very, very carefully to prevent that. And who's better at security than Google, right? Like we're entrusted with a lot of the world's data, and we know how to protect that. And so we do tests where we hire the world's best hackers and bring them in and let them touch the car and let them understand our car and tell them, please attack it, please show us where our vulnerabilities are so that we can make sure that they're not hackable. We've also done really smart things like separate where the software communications are from the stuff that's inside the, just typical architecture stuff. We also, nothing's in the cloud for the Google cars. A lot of people think that our stuff is in the cloud. It's not. It's all local. It's all on board.
We have another question, but
No problem.
What do you do for fun?
What do I do for fun? Well, I have 2 little boys, and so most of the time I chase 2 little boys around, and that's pretty fun. They are 2 and 5, so seeing life through their eyes is amazing.
Any other questions? These are some great questions so far. Yep.
Do you plan on making a self-driving Lamborghini?
I don't think we're planning on a self-driving Lamborghini.
Monster truck?
Monster truck. That's a great idea.
You need this guy on your team. Hello, over here, in the back.
Yep.
Hi.
Hi.
How do you talk to people when they hear your amazing background, and then when you tell them that you have 2 kids? Like, how do you juggle your daily life? How can you do it? Like, because people are afraid of people working and having kids.
Yep.
And women, I know because I'm a woman, we can do many things. You don't just have to be a mom, or you don't just have to be a professional. How do you talk to people about that? And what would you tell the girls in the audience, that they can be everything and anything that they want?
That's exactly it, right? Is like what is it that you want to do with your life, and what is it that your dreams are, and what are the stars in your world, and then just never say no, right? Like I have 2 kids, I have an amazing husband, and I have an amazing career, and you can have it all. You have to figure out how to balance it and how to juggle it, and you have to be easy on yourself, right? Like it's not an A+ job every single day on every single front. You got to figure out like where it's important to get an A+ and where a B- is still okay, right? Like my house is probably dirtier than I would like it to be. The dishes probably aren't done. I don't think I've folded laundry in 3 weeks. My kids are just pulling their clothes out of the laundry basket. It's clean. But figuring out what's important to you and then making those things true and figuring out how to make them true.
Oh, we have one more. Here I come.
When are we gonna see flying cars?
Flying cars. I have a friend, Beth, used to work for me at JPL, and now she's working at a company called Terrafugia. You guys should check it out. And they have cars that can fly, and she's up flying every day, and then they land and you can drive. The big problem with flying cars is figuring out the infrastructure of like, how do you land, how do you take off, how do you do traffic control? And so really the technology exists. It's the United States doesn't have the infrastructure and the policies around making that a viable technology yet. And so a lot of the problems are that you can have amazing technology, but you have to have a way for it to actually be usable in the United States. And that's kind of the bigger problem with flying cars right now.
Great question. Wow. All right. Any last questions? So I have a last question, actually.
Yeah.
It sounds like you've just done so many incredible things, and that you really believe that anyone can do those things. So what advice would you give the students here today in terms of what their interests are and what they hope to do in the future and how they can pursue those things?
Absolutely. I think you have to know what you're passionate about. Like if I asked you what are you passionate about, who can answer that question? If you can't answer that question, you need to figure that out first. Like that's step one. What is it that makes you get up and be inspired and want to go to work or go to school or whatever it is, right? Because school's hard, work's hard, and you've got to like just be lit on fire, and then you can make anything happen. And so I think the first thing I would tell everybody is like be able to answer the question, what is it that I'm passionate about?
Wonderful. Thank you so much. And let's all give Jaime a huge round of applause.